All right. Hi, can everyone see and hear?
Good to go.
Good. Okay. Today I'm going to be sharing with you our recent developments in workflow optimization using xenobiotic biotransformation networking to help identify undocumented xenobiotic exposures. But first, I'm going to start with a quick summary of our general mission statement. Our project's focus is the development of a strategy for high throughput generation of xenobiotic metabolites to create reference libraries useful for identification of xenobiotic exposures in human samples. Here is a refresher of our strategy as described in a paper published last year. First, we incubate xenobiotic precursors with pooled human liver S9 fraction, which contain most phase 1 and phase 2 enzymatic activity. And we monitor the reaction products with mass spec, curate a library of these precursor to product relationships along with associated mass spectrometry data, and use it to help identify xenobiotic exposures in human samples in which related metabolites are co-detected. And we did all of this data analysis mostly by hand. So now we're working on applying this approach to large scale untargeted human data with mass spec reference data curated from over 1,000 xenobiotic reactions. Manually rifling through the data isn't really cutting it. So our solution to scale starts with using Python to rapidly group unique features from these S9 extracts into metabolite sets, with each set containing precursor and product MZs and RTs. These can be used as xenobiotic exposure profiles of sorts that can be found in human samples exhibiting the exposure. Here's an example that we can follow along with the workflow. Here's a visual of the nicotine metabolite set that we pulled from experimental data. We have this information for about 1,000 xenobiotics right now, and we're continuing to expand that number as we keep running through mass spec. We can actually make searching for these profiles in human data easier with some pre-processing of the aligned human data set. Can reorganize these features into networks containing likely xenobiotic exposures ripe for library screening using a few assumptions. We assume exposures are not ubiquitous across all individuals, that metabolic pathway members should co-occur with one another, and precursor product mass differences should be consistent with some common biotransformations. Based on these assumptions, we performed feature-based network analysis using Python's NetworkX package to arrange co-occurring features as defined by cosine similarity, whose masses differ by a predefined list into these candidate exposure networks. Here are all of the candidate networks we extracted from one study with samples from 50 volunteers. You can zoom in on one of these networks to show all of the network features. Next up is how we can actually map these candidate networks to the reference data that we generated from S9. This is pretty simple. We can just compare all of the sets from S9 with all of the nets from human data and scan for overlapping features within MZ and RT retention time tolerances. This allows us to quickly prioritize potential exposures for further investigation. Here's that in action with the nicotine example. Here's the feature set. And here is an example network. And here are the 4 overlapping features that we found between the 2 of them. This indicates a likely exposure. And when we actually look at these features, we can see that MZs correspond with nicotine and its metabolites. And we can actually identify the exposures themselves within the population by looking at these feature intensities in a few slices among the cohort. So we've demonstrated an efficient strategy for using mass spec data we've collected from xenobiotic reactions to map out exposures in large scale human data set. Accomplish this by automating generation of xenobiotic metabolic feature sets for a reference library, applying network analysis to human data sets for quick isolation of good candidate xenobiotic exposure pathways, and bringing those 2 concepts together to help prioritize likely xenobiotic exposure candidates for further validation. This approach appears to provide a practical solution to identifying exposures in human samples for non-targeted analyses, and its power should only increase as we keep continuing in our curation of xenobiotic biotransformation products. These are all the people that I work with. Take questions if you have.
Thank you very much, Grant. I think we'll proceed from